on Friday, so a lot of kids weren't going to be there, so we changed it to Monday, tomorrow.
Okay, great. All right, well, yeah, hopefully by now, I would think the goal would be like, you yourself even are like, oh, I know that, or yeah, that looks, I'm feeling really confident that you can do these on your own here.
Yeah.
This one right here is just a known antiderivative. It's, oops, that's a bad color. Am I sharing my screen?
Yeah.
Okay. Let me switch to a different color here. This is tangent of theta evaluated from 0 to pi over 3. It's just a known antiderivative, no u-substitution, just you got to know how to do it. So this becomes the tangent of pi over 3 minus the tangent of 0. Tangent of 0 is 0, tangent of pi over 3 on your unit circle, that's the angle that's a little bit higher up. That's 1/2 comma square root of 3 over 2. It's y over x, so it's square root of 3 over 2 over 1/2. So minus 0, so this ends up equaling just the square root of 3.
Okay. Perfect.
Okay, number 5, every other odd is what I saw there, and let me know if I go down the wrong path here, because so I mentioned I think we talked about this, like whenever you get a sine and a cosine pair like this, you always make your u the one that's to the power. At least in this class. There's some variations on that. Your du is cosine x dx. Okay. And then whenever whenever it's a definite integral and you're making a u substitution, usually it's a good idea to evaluate it. So sine of 0 is 0. U of pi over 2, or evaluating sine of pi over 2, that's 1. That's at the top of the unit circle. Because when you change the limits of integration with this u substitution, usually they get better. It's rare that they get worse, at least in textbook problems. So we have 5u to the 3/2 cosine x, and then our dx, we're supposed to solve it for dx. That's du over cosine x. And you can see that those cancel. You can move the 5 to the outside if you want. Integral 0 to 1, u to the 3/2 du. And that's u to the 5/2. Now, maybe like when you divide by 5/2, like what I would really want you to do as a student is I don't want you to realize, oh yeah, I just flip it right away. Like I don't even want you to write this. I want you to write the reciprocal of this, u to the 5/2. You can also see that when you multiply these, you get 1. 5/2 times 2/5, you get 1. But then there's also this 5 that comes out in front also. Value from 0 to 1. So the more you can cancel out and do would be better. This becomes 2u to the 5/2 from 0 to 1. 2 times 1 to the 5/2 minus 0 to the 5/2. And 1 to any power is always 1, so this just equals 2.
Okay.
After all that.
Okay.
All right. Number 9. All right, so first thing I see on the bottom here is the bottom can be factored, x plus 2, x plus 3. But the numerator isn't really all that nice for that. It's leading me to partial fractions because like a u substitution on the bottom would make your du 2x plus 5, which doesn't cancel. So that doesn't help much here. If it was a perfect square trinomial, that might help, but this is definitely a partial fractions problem. So you got x over the original x squared plus 5x plus 6 equals x plus 2a x plus 3b. So another way to write the numerator is 1x plus 0 equals, and then you're multiplying the top and bottom by the other one. So this is x plus 3, x plus 3, x plus 2, x plus 2. Yeah. So ax plus 3a plus bx plus 2b. And then you set your x coefficients equal. So 1 equals a plus b. and then 0 equals 3a plus 2b.
Okay.
So I guess I would multiply this by, I don't know, -2 maybe. So -2 equals -2a minus 2b. Then you add them. So a equals -2.
Okay.
And then you put that back into this first one. 1 equals a plus b. And maybe you can just see it here. A is -2. So b must be 3 to make that work. So you do all that, but you're not even close to done. You still got to go back to the original problem, which is the integral from 0 to 1.
Mhm.
Instead of this thing over here, you're going to write -2 over x plus 2 plus 3 over x plus 3 dx.
Gotcha.
Okay, and then these are both natural log absolute values.
Mhm.
And 3 natural log absolute value x plus 3, evaluated from 0 to 1.
Gotcha. Okay.
You could combine these. I probably wouldn't. I would just work it out. -2 natural log 1 plus 2 plus 3 natural log 1 plus 3 minus big parentheses -2 natural log 0 plus 2 plus 3 natural log 0 plus 3.
Okay.
So -2 natural log 3 plus 3 natural log 4 plus 2 natural log 2 minus 3 natural log 3. So the reason I'm doing all this is because you get some things that combine here, like the first and the third combine, or first and the fourth combine. They make -5 natural log of 3.
Okay.
So that takes care of those two. Now, interestingly, if you bring this 2 here, this becomes the natural log of 4 because it's 2 squared, which is natural log of 4. And
Mhm.
then that combines with this one. So you got 4 natural log of 4s. You got 4 of them. And then you could, I mean, I don't think you need to do all this, but like, I think you might be expected to go here, but you could bring the 4 up here. So it's 4 to the 4th over 3 to the 5th, and then combine them.
Okay.
You might see in the back of your book, it's 256 over 729, something like that.
Okay.
Anyway, this isn't algebra. This is just, or this isn't calculus. This is all just other stuff. So, okay, 13. 13. I remember there being some significance to them being in red when the problems were in red. I don't remember what that is though. So this is somewhat similar to the previous one, but it's a u substitution, because when you take the derivative of your u, it's already in there. The t is already in there. You don't have like a 5t or something else to sort of mess things up here. So you have the integral t dt over u, and then instead of dt is du over 2t. So I shouldn't have wrote that. Get rid of that. Okay, so it's du over 2t integral 1/2 1 over u du.
Mhm.
Yeah, those cancel.
Yeah.
So this is the natural log of the absolute value of u 1/2. Now there's no limits of integration, so this time it's plus c, and then you have to back substitute your u.
Okay.
So far we've done just a straight integral rule, 2 u substitutions, and a partial fractions. Does
Mhm.
that kind of feel like what you might have on your exam? Is that okay?
They put a picture on the board on Friday of what is going to be on it. Okay. It's evaluate the integral, and there's going to be one with substitution, one with parts, one with partial fractions, one with general algebra, and one definite.
Okay.
And then solve the initial value problem. There's going to be 2 of those. and then one slope field, one problem with Euler's method, one linearization.
Okay. Yeah, I mean, that covers all of it. The issue is like, well, which one is which? And
Yeah.
there's really no way to know because there's so many different types of problems you could see here.
Yeah.
So any idea what your U might be on this problem?
It would just be the natural log of x.
So that's a good guess, and I think that's correct here. That you'll notice that its derivative is already in there.
Yeah.
So I mean that's a good start here.
Mhm.
So this integral, instead of dx, I'm going to write just a 1 over x u, and then instead of dx, it's when you solve for dx, it's x times du. So x times du. So it does work out really nicely where those x's cancel.
Mhm.
And the integral 1 over u du. So your answer is the natural log of the absolute value of u plus c. Your u is the natural log of x, so it is the natural log of the absolute value of the natural log of x plus c as your final answer.
Okay.
So try not to get like, don't get consumed by if it's really awkward, because I mean, this is just the way it is. It's not, it doesn't mean anything, but it is the answer that you're looking for.
Yeah. Okay.
Okay, 21. Okay, so 21 is a integration by parts problem.
Okay.
And how do I know that? It's because it's of this form, e to the x times either a sine or a cosine.
Yeah.
Those are always integration by parts. Your u here, and this is my choice, is I choose the one that's easier to take the derivative of. So we're comparing we're comparing e to the 3x as the derivative choice versus integrating it. When you integrate it, it's really a u-substitution problem, but a derivative problem, it's a chain rule. And most students are pretty comfortable with that by now.
Yeah.
And that 3 just comes here. Whereas let's just say you made dv e to the 3x. Your v would be 1/3 e to the 3x. And that may be slightly harder to do. So that's why I don't recommend doing that. Your dv here is the other term. It's the sine x dx.
Yeah.
So your v is minus cosine x.
Okay.
All right, so integration of parts is uv minus integral v du. When you get this style of problem, you have to do it twice. Okay, so we're gonna have to end up doing this twice, but let's just piece it together. It's e to the 3x times negative cosine x minus integral v du. So that's minus cosine x times 3e to the 3x dx.
Yeah.
And so I'm just gonna rewrite everything down this line below, because we do need the left side, the original part of the problem, sine x dx equals, this is negative e to the 3x cosine x. So another thing that's important to do is to keep the order, exponential, then the sine or the cosine. That's a good thing to do here. Plus, these two make plus integral 3e to the 3x cosine x dx. And we're only halfway there. We gotta do it again. So this is what you're doing your integration by parts for. Your u is 3e to the 3x, and your dv is cosine x dx. So your du is now 3e to the 3x times 3. So that makes it 9e to the 3x dx.
Yep.
Your v is the antiderivative of cosine, which is sine x. And then you just do the same thing again. I mean, it's a lot of writing. They're pretty horrible, but we'll just come down. This is our plus. Put that right there. So your u this time is 3e to the 3x. Your v is sine x minus integral v, which is sine x, and your du is 9e to the 3x dx. And then I have the advantage here of being able to just copy and paste here. Let me see if I can. Oh, it was weird. Okay, there it is. So what should jump out at you is that this right here, especially when I rewrite it, and I'm gonna bring the 9 out, 9 e to the 3x sine x dx. This is the same as the term over here on the left.
Yeah.
And that is the case. Like maybe there's a coefficient in front, but it's exactly the same. Move this more clear that that's a minus. So you're adding 9 integral e to the 3x sine x dx to both sides. So you're adding that, and you're getting 10 integral e to the 3x sine x dx, and then you just bring these other terms down. So negative e to the 3x cosine x plus 3e to the 3x sine x, and you divide by 10, divide by 10. So integral e to the 3x sine x dx equals exactly this, but then there's the plus c. You don't want to forget at the end.
Yeah.
Okay, so it's integration by parts twice, and they're always that way when you get one of these e to the x sine x or cosine x problems.
Mhm.
Like if I were giving you this exam, I would just change the 3 to like a 2, or make sine x cosine x. Like I wouldn't, that's the minimal change I would do, because you're testing like, can the student go through these steps?
Yeah. Okay.
Are there any other integrals there that you want us to look at that maybe stand out to you?
No, that looks good.
Okay.
Get it?
All right, so 25 is an initial value problem. It's really a differential equation, but they're calling it an initial value problem because this is the initial value that they're giving you.
Mm-hmm.
And in other words, you're going to be able to solve for C when you're done, the constant of integration.
Yeah.
Okay, so I mentioned this before, like you want to move this dx over here. And if there were y terms, you would move them over, but this becomes the integral dy equals the integral 1 plus x squared over 2 dx.
Yeah.
So on the left, it's just y, right? It could, we did somewhere it was over y, and then you got the natural log of y. It could be really anything. We'll see that here. The integration here is the power rule, right? You're going to add 1, divide by the new exponent each time. So this is x plus x squared over 2 plus x cubed, and then there's a 2 and a 3 on the bottom. So if you can immediately go to like x cubed over 6, that's even better here.
Yeah.
So now we use our initial value. Our initial value is y of 0 equals 1. So you put 1 in for y, 0 in for x. And you get that c equals 1. And then you put that back in here. So your instructor is looking for a final line. Actually, this line's better. That's complete. If you don't write +1, even though you solve for it, like somehow that's not correct, even though you found all the information for it. Okay, so 29, is that our next one?
Yeah.
This looks a lot like that review thing you showed me our last couple of lessons. Maybe that's where they got the problems from.
Yeah.
Okay. This one, they give you 2 initial values. And what that means is you're going to have to do it. You're going to have to integrate twice. So there's no y's to move over here, and that's not important at the moment. but you do want to, you basically want to integrate d squared y equals integral 2x minus 1 over x squared dx squared. You're basically you're going to integrate it twice, but because on the left you get dy after you're done, or y prime. That's another way to write it.
Yeah.
The first one here is x squared. This one is really x to the minus 2, but then you have to, this is just a rewrite of it. You want to then apply the power rule. So it becomes, you know, you're adding 1 to that, so it becomes to the -1 power over -1, the negative cancels that. It ends up being this.
Okay.
Right. And then from here, you can apply that first one, that y prime of 1 equals 1. So to do that, the you know, you treat this over here, because there's really a plus c here, that you treat this as your y effectively. So 1 equals 1 squared plus 1 over 1 plus c. So it ends up that you know, c equals -1.
Mm-hmm.
So if we go back to this previous line here, we got dy equals x squared plus 1 over x. And then I wrote it over here, it really should have been in here, I guess. So that's c is -1 dx. Now you're going to integrate both of these again.
Okay.
Y equals 1/3 x cubed plus natural log opposite value of x minus x plus c. And then you've got this other initial value, y of 1 equals 0. So 0 equals 1/3 1 cubed plus natural log of 1 minus 1 plus c. This is 1/3 plus 0 minus 1. So these two make minus 2/3. We add 2/3 over here. So you get 2/3 equals c. Then you go back to this line right here and substitute in your constant of integration.
Okay.
Here's your final answer for that one.
Okay.
Okay, is 31 the next one?
I think 33.
33, okay. Yep. Okay, 33. All right, 33. This time we do have some y's, and maybe there's like a thought like, oh, I'll just distribute in. You don't want to do that. You generally multiply or divide to move y. You never add or subtract, I guess is the point. So you divide by this, and on the left, I'm sorry, on the right over here, it leaves 1. This equals 1 dx basically, or I guess it's dt. I move the dt over.
Okay.
And then on the left, it's integral dy over y times 1 minus y.
Yeah.
So the left here is partial fraction. So it's 1 over y times 1 minus y equals a over y plus b over 1 minus y. And then bringing this down here, this is like 0y plus 1 equals, and then you multiply the top and bottom by the other one. So this is going to be times y times y. You just care about the numerator. So it's a minus ay plus by. So we have 0 equals minus a plus b, and 1 equals a. Hey, look at that. That's nice. Okay, so the a is solved for.
Mm-hmm.
So b equals a, which equals 1. If you go back to this line right there. Okay, great. So on the left, you have to break this apart. So that it becomes integral a, I'm sorry, we have a 1 over y plus 1 over 1 minus y dy equals integral 1 dt. So you have natural log absolute value of y plus, now this one right here is really a u substitution. This one in the middle, this is u equals 1 minus y, du equals minus dy. So when you integrate it, you're really integrating 1 over u, but then this negative comes over here with the du, so it becomes negative du. So you get negative natural log absolute value of u, and your u, you back substitute this 1 minus y back in here.
Okay.
So it looks really similar. You might think, oh, well, hey, Matthew, it's kind of the same thing. It is. It's natural log absolute value 1 minus y. But you have to remember that when you take the derivative of 1 minus y, you get a negative. That's why you have to undo it with the negative out here.
Okay.
The right-hand side is 1 dt. So that just becomes t plus c. Then we have this y of 0 equals 0.1. That's your initial value. So we go natural log 0.1 minus natural log 1 minus 0.1 equals 0 plus c. So on the left here, so this is natural log of 0.9, and then you can use the property where you're subtracting, it becomes a division. So it's 0.1 over 0.9 equals c. And I guess you could simplify a little more. This is natural log of 1/9. So some instructors want you to write natural log of 1 minus natural log of 9. Natural log of 1 is really 0. So this is minus natural log of 9 equals c. You know, there's so many things you could do here. 9 is really 3 squared. So you could write minus 2 natural log of 3. I don't know where you stop, but one of these is your c. And then you go back to this line right here. And then the question is, do you need to solve it for y? And you know, I don't know. Let's put let's go minus natural log of 9. So this one's pretty tough to solve for y, because you'd have to write natural log of y over 1 minus y, and then you'd have to use e on both sides.
Yeah.
Tell me when to stop here on this. Do you want me to keep going?
I have no idea where they would want us to stop. We haven't really done a problem like this in class, so.
Okay. You know, this one right here, like this negative comes up here, so it becomes negative, or in 9 to the negative 1, it's 1/9. So this ends up being y over 1 minus y equals 1/9 e to the t. And from here, it's possible to solve for. It just becomes pretty, yeah. So.
Okay. Yeah, that's fine. We can leave it like that.
Okay.
We can move on.
37?
Yeah.
Okay. So the slope field and we did a slope field problem together last week. That was much more complicated than this one, because, and I think you'll find that this is more of the type of problem you'll see on the exam here. So the derivative here is negative x, and in words, this means the slope is negative x. Okay, so like I like to set it equal to, try to find it where it's equal to 0 or equal to 1 or equal to -1, because these are the nicest slopes that you can find. Like a slope of 0 is a horizontal line, 1 is up and to the right, -1 is down and to the right.
Mm-hmm.
Okay, so like you almost have to like set, you don't want to pick ordered pairs. Like I know that's maybe what you did. Ordered pairs works well when it's contingent on both x and y. So like when let x equal 0, that's true everywhere along here.
Yeah.
Okay, so what is -0? Well, it's 0. So all of these have this horizontal slope.
Yeah.
Okay. Now let's let x equal 1. So So that's true all along here. X is equal to 1 all along here. But the dy dx equals -1.
So
So
go down. Oh,
yeah. And it just so happens that when you let x equal -1, that means dy dx equals -1, which equals 1. So these go all up and to the right.
yeah.
Can you just excuse me for 30 seconds?
Yeah, no problem.
Okay, I'm back. So we could do another one of these if you wanted, like y dx equals -y or something like that. But practicing these on your own, you don't want to make them more complicated than like one variable.
Yeah.
I'm guessing.
Yeah, no.
Okay, so is 41 the next one?
Yeah, 41.
Okay.
It's the last one for the every other odds.
Let me switch back to my correct color here. So the next one is they give you 4 slope fields. There's your 4 slope fields. And then they also give you 4 equations. Now you're just asking to do 41, but if you were given this problem, like let's say you were given 39 through 42, you'd want to use like elimination to like, oh, it's not that one, or this one's that one, and
Yeah.
so on. So this one does depends on both X and Y.
Mhm.
Okay, so but what you're still trying to do is we'll figure out where's dy dx equal to 0, or dy dx equal to 1, or dy dx equal to -1. Okay, now this is the one that should come to mind.
Yeah.
First. So
a little
for,
limit.
so for what values of x is x times y equal to 0? When x is 0, right? If x is 0, y could be anything because 0 times y is 0. And 0 over 10 is 0. So x equals 0 occurs along the y-axis. So do you see here how a along the y-axis has a slope of 0, and same with c?
Yeah.
So these are out.
Yeah.
When y equals 0, we also have this condition. Okay, because if y is 0, anything times 0 is 0, 0 over 10 is 0, and that's along the x-axis. Now that doesn't help us much because it kind of looks like they're all there.
Yeah.
Okay, so now it's like, well, what do? Notice like what I'm seeing in the first quadrant, I'm drawn to the first quadrant because both x and y are positive there.
Mhm.
What do you notice is different about the slopes? Like these are going down and these are going up.
A, they're all going to be like negative, and C,
Right.
they're positive.
So if and you can just pick a point, like I don't know, like 2, 2, is the slope positive or negative? Well, it's positive because 2 times 2 is positive, positive or positive, positive. So C is the correct answer.
Okay.
And that's how you would do it. This would be really hard to do because of the 10 by hand. Like you could maybe do x times y, but I'm not sure you could do much more than that.
Okay. Yeah.
Okay, 43.
Yep.
All right. Okay, suppose dy dx equals x plus y minus 1 and y equals 1 and x equals 1. Use Euler's method with increments of delta x equals 0.1 to approximate the value of y when x equals 1.3. Okay, so your current y is this. So you would actually assign that to be y1 or y subscript 1. So you would maybe write, you'd maybe want to write out your, how do I want to do this? Let's do this. Let's make a table. So Okay, y1 is 1, x1 is 1. Okay, and so you also generally need to evaluate dy dx at that point.
Okay.
So it's 1 plus 1 minus 1. So that equals 1. So now y2 is going to equal y1 plus the derivative. I don't really want to get you caught up on notation, so I'll just write the dy dx times the delta x. And it's almost always like we had a problem that was really weird, that where it went backwards, which I mean, I guess is reasonable, but it's never taught that way. Like we're always going forward. Delta x is always positive. So for you, your y2 is 1, because that's your y1, plus the derivative times 0.1. So notice this equals 1.1. So your y2 is 1.1. Your x2 is, it's x plus your delta x. So it's 1 plus 0.1. So it's 1.1 also. It just so happens that these are the same. That doesn't usually happen. Dy dx is, you go back to here, x plus y minus 1, but you use your x1 or your y1. So it's 1.1 plus 1.1 minus 1.
Okay.
So it's 0.2. So your y3 is
Wait. 1.1 plus 1.1, that's 2.2, right?
yes, so it's 1.2. Yeah,
Okay.
good. Yeah, I make mistakes, obviously. And so then y3 is it's really your y2. Let me write out y2 plus dy dx times your delta x.
Okay.
So your y3 is 1.1 plus 1.2, and then your delta x is 0.1.
Okay.
So you don't need a calculator. I mean, 0.1, you're moving the decimal over. So it's 0.12, so this becomes 1.22.
Okay.
Now, x is 1.3, so we're not there yet. X was 1.1. We got to do this a couple more times. Yeah. Okay, so I'm gonna skip doing this for the moment. So your y4 is 1.22 plus. Now we have to evaluate the derivative with our new x3. I guess I didn't need to do this. Is 1.2. Your y3 is 1.22. So that's x plus y. It's 1.2 plus 1.22 minus 1 times delta x, which is 0.1.
Okay.
I definitely need a calculator for this one. I think 1.24, 1.42, 2. Maybe. I don't know if you got a calculator. The numbers aren't really that important, but you want to get them right on the exam. It's the steps that matter here.
Is it? Maybe I calculated it wrong. So 1.2 plus 1.2
I did this by hand, so maybe you probably got the right answer.
times 0.1 plus 1.22. No, you got it.
Okay, great. So your y4 is 1.362, and your x4 is now 1.3 because you add delta x each time.
Yeah.
Now another thing, I know throwing a lot at you. Sometimes like this is really y0 and x0. Don't try not to worry about that. I mean, you just follow it through, and so you get to the x value that you need. Yeah. So y5, this is the final one, 1.362 plus. You go back to your differential equation, which is x plus y from the previous step, minus 1 because that's what was given, times 0.1, and that is your final answer there.
Okay.
Whatever you get for that.
Yeah.
You'll find that this is not a hard calculation to do once you've done it a time or two.
Yeah.
So please practice it if you have time for the exam.
Okay.
All right, 49. Okay. This is somewhat similar to the, let's see, which question was it? We did an initial value problem earlier that had a second derivative. It's a lot like that. Let me go up and just making it like just so you can see it's.
Give me 1 second. You go talk
Sure.
to Mike. Just give me 10 seconds.
Sure.
Sorry, I'm back.
Great. So what I was trying to get to is that this is really like 29, but it's a word problem. But it's the exact same process. You have to find an antiderivative twice. It's a double initial value problem.
Okay.
So S, if you, I don't know if you've taken physics, but S is considered the position function, V is velocity, and velocity is the derivative of position.
Yeah.
And A is acceleration. And it's two things. It's the derivative of velocity, but it's also the second derivative of position.
Yeah.
Okay, so all of that being said, you just need to find the antiderivative of this. Okay, so the antiderivative of this, it ends up just being V because the antiderivative of this is the first derivative is position. So you're integrating 2 plus 6t dt. So it's 2t plus 3t squared plus c.
Okay.
And then you're given an initial value. You're told that the initial velocity is 4. It says when t equals 0, velocity equals 4. So 4 equals 2 times 0 plus 3 times 0 squared plus c. So c equals 4. So you go back to this line right here. V of t equals 2t plus 3t squared plus 4.
Gotcha.
Okay, let's do a part B. Okay, part B. So this is kind of your AP question style question. It says, how far does the particle move during the first second of its trip? If you recall, if you're given the graph of velocity and time, and this is from 0 to 1, the how far or the distance is the area under the curve. So it's the integral from 0 to 1 v of t dt.
Okay.
So for us, that means the integral from 0 to 1, 2t plus 3t squared plus 4 dt. You could use your calculator for this if you have it, the Math 9. If you're doing it by hand, you got to find the antiderivative.
Okay.
And you evaluate that from 0 to 1. So it's 1 squared plus 1 cubed plus 4 minus 0 squared plus 0 cubed plus 4 times 0. So that looks like it equals 6. You need units because it's a real physical problem. We have to go back and look. It's meters per second. So it's 6 meters.
Perfect. Okay.
All right. What's the next problem?
59, I believe.
59, okay.
Yeah, I think it's 59. Yeah.
Spread of the flu in a certain school is given by this formula, where T is the number of days after the first students are exposed. Share the function as a solution of logistic differential equation, identify K and the carrying capacity. Okay. So this starts out dp dt equals something, which I don't remember. I think it's like, I need to look. You would not get this question on exam because you would, they're more interested in you solving it. This is just like, can you use the logistic differential equation?
Okay.
Just let's see if I can find it. So I think it's like this, p times 1 minus p. It's like the one we solved earlier.
Mhm.
But this one actually wants you to derive it and then solve it. The carrying capacity is what's called, maybe we can talk about that because that's more specific. The carrying capacity is the limit as t goes to infinity, p of t.
Okay.
So it's like, well, what happens when t gets large, like over time? So we can do that here. If it's one, sorry, let me go back up. Here. So when t gets large, it's 150 over 1 plus e. T is really large, so it's negative infinity.
Okay.
Or e to a negative, really large number, right? And that becomes the following. It's 150 over 1 plus 1 over e to infinity. E to a really large number is a large number. 1 over a large number is 0. Becomes 150 over 1 plus 0. So it's 150.
Okay.
So they don't say what P is. P must be the number of people. So long-term 150 people are going to get the flu in this case. And it's solved from some, I think it's this one, but there's variations. It's actually if you want the full form, it's 1 minus P over K times P. You probably have it in your textbook there. They probably don't use all these variables, but the growth rate, the K is this number right here.
Okay.
K is the 4.3.
Okay.
All right.
Cool.
Does take us to the end of our
Yeah.
lesson. So sorry we couldn't get through everything, but
We got pretty far.
yeah. Yeah.
Good.
So best of luck on your exam. If you have some time, review, you'll do great. And I'll see you next time.
Okay. See you next
Have a
time.
great day. Bye now.